By 2050, more than half of the cities in Florida will be underwater. And that includes your next vacation destination. Well, I'm not trying to scare you. I'm sure most of you here can swim. But why is this the case? For many years, the Earth's temperature has been steadily increasing without being checked. And this is because we love industrialization. And majority of the energy we use comes from the burning of fossil fuel, which actually releases greenhouse gas into the atmosphere. Now, a familiar face in this environment is actually the use of transportation, which includes the shipping vessels, which is the focus of my conversation today. Shipping vessels include your yacht, boats, and cruise ships. After a period of time when they are used, there is the accumulation of foulant, which are microalgae, which become stuck on the surface of this boat. And that actually causes drag when you use these shipping vessels on the water. And this drag in turn causes you to burn more fossil fuel, which increases the Earth's temperature, like I'm talking about. Now, this is where my work comes in. Because previously, the International Maritime Organization has banned the use of toxic antifouling coatings. And in the years of my PhD dissertation, I've worked extensively on the development of new antifouling coatings made from polyelectrolyte multilayers. So first, what are polyelectrolytes? Polyelectrolytes are actually plastics. You find them all around you. But these plastics are very different because they have a charge on them. For example, a polycation is actually used in your everyday shower. So if you've do a very good shower today, you use some of that in your shampoo. So because they are water soluble, we are able to produce polyelectrolyte multilayers from them. And what we do is we stack the oppositely charged polyelectrolytes on top of each other, like you do for your sandwich. And then what you get is a polyelectrolyte multilayer that is dense, tough, and actually well hydrated. Now, in the laboratory, we're able to test the performance of this material as antifouling coatings by exposing them to a model foulant, such as green algae, which is actually responsible for the greenness on the ship vessel that I've shown you, which in turn causes greenhouse emission. Now, we then flow a media through them, trying to mimic what will happen when you use your boat on the water body. What we observe is that experimental results shows that without our coatings, like you can see in a control, there's persistent fouling. That is, the algae remains stuck to the surface, which will then cause the issue of global warming, like I talked about. Whereas when you coat our surfaces with the polyelectrolyte multilayer, they're able to prevent adhesion of this foulant. And are actually, because they are very well hydrated, they have a favorable surface charge, which is net neutral, and they have able to withstand harsh operating conditions. This recently has gained the attention of the US Navy. And with this, we hope to tackle the issue of global warming, actually starting at the surface. Thank you.